So today we're going to do a science experiment and with some of the things that we've been learning along the way. Now, when we talk about doing science experiments, we have to remember our first rule. And what would that first rule be about? That starts with an S.
Safety.
Correct, safety. Now, whenever you're doing, let's say you became a scientist later in life, and you wanted to do an experiment, you would have to take the proper safety precautions because you may not know how things are going to go. You don't want anything blowing up in your face or anything like that, right? So one of the safety features we could use is a safety mask. This would prevent any type of gases from coming through. Okay? Another type of safety equipment we might want to use would be something we put over our eyes. Do you remember what we put over our eyes in the lab?
Safety goggles.
Safety goggles, that is correct. Now, I happen to know that the experiment we're going to do today is completely safe. I've done this experiment before. Many people have done this experiment. There has been no danger with this. Okay, so I just wanted to ease your mind on that. All right, so the second thing we want to do when we do an experiment is gather our materials and have them in place so we don't have to hunt for them. Can you pick up an item and tell me what these items are that we're going to be using?
Water bottle.
A water bottle.
Balloon.
A balloon.
Baking soda.
Baking soda.
Distilled white vinegar.
Vinegar.
Funnel.
A funnel. And why do we use a funnel? Because it's fun. Now, what is this here?
A dish.
A little dish, correct. And lastly,
Measuring spoon.
a measuring spoon. And this one happens to be how much?
Half a teaspoon.
Half a teaspoon. Okay? We'll be winding up using more than half a teaspoon. As a little side lesson, if we wanted to use 2 teaspoons, and this is half a teaspoon, how many scoops will we need?
4.
Good math. So over the past few weeks, we've talked about other science topics, such as certain types of changes. Now, one change we talked about was a physical change. Can you think of the other type of change we discussed?
Chemical change.
Chemical changes. Now, those are completely different things, although they can have some similarities. Can you give me an example of a characteristic of a physical change?
Change in form.
A change in form. Can you think of another one?
A change in color.
Change in color, that's good. Now, I want you to remember that those can also be characteristics of chemical changes, but there's a clear difference between the two. Okay? With physical change, once the item has changed, it can easily go back to its original form. Okay? Can you think of an example to show the class?
Piece of paper. You can crumple it into a ball. And it changed. And then I can uncrumple it and flatten it out.
And it's back to its basic original form, except for a few wrinkles. But it's still a piece of paper. Now, with a chemical change, this is something that couldn't change back. So what could you do to this piece of paper to cause a chemical change?
Burn it.
You could light it on fire. It will burn and turn into ash. And could you take those ashes and glue them back together and make this piece of paper?
No.
No, that would be near impossible. So that is an example of a chemical change. Now, one thing we need to do before we do the experiment is go over some terms that are going to be very helpful for us to understand what is going on. The first term we want to talk about is combine. Can anyone give me a definition of the word combine?
When you put 2 or more items together.
Yes, at least two items. It can be more than two. When they come together, they are combined. What about the word substance? Do you know what the word substance means in like a simple definition? It has to do with a word that begins with M.
Molecules.
Okay, well that's very interesting because substances are made of molecules. But when a bunch of molecules come together, they become this M word that begins like if you were to rub your feet on a door mat. So the word that we're looking for is
Matter.
matter. Okay, so that's what a substance is. Any kind of matter. All right. Next, we have a very interesting word, and the word is reaction. Now, how do we define the word reaction? Does anyone know? Can anyone help Amanda up here? Well, let me help Amanda up here. A reaction is basically when two substances come together. Those substances are going to affect each other and behave in a certain way. Now, I heard that you're allergic to bees. Is this true?
Yes.
Okay. What happens if you get stung by a bee on your arm? What happens to your arm?
It swells up.
Pretty bad, right?
Yes.
Okay. So what that is then, that swelling, is the reaction. And the two substances are what? Your skin and
Bee venom.
the bee venom. So those two substances coming together forms the reaction. Okay? And the last word we want to talk about is chemical. Now, we didn't go over this one quite yet, but we need to understand what it is. A chemical is any type of substance that has a specific composition. Okay? Now, what we want to talk about here, when we look at this baking soda, this is a substance. Okay? Substances are made of molecules. A whole bunch of molecules coming together to build this matter. Okay? Now, if you look at just baking soda, it's like a powder. You see? It's like a powder. And the powder is made up of 4 things. And I have a little model here to show that there's 4 different types of molecules that come together and they are connected. They are bonded together, okay, to form baking soda. Actually, what this is this whole thing is a molecule. So I believe I misspoke. Each one of these is a separate type of atom. There's 4 distinct atoms that come together to make one baking soda molecule. We're only going to be concerned with one of them today. And that is CO2. Do you know what CO2, the long word version of CO2 is?
No.
It is carbon dioxide. Okay? Now, carbon dioxide is what we breathe out. We breathe in oxygen, breathe out carbon dioxide. This one is the carbon dioxide. Okay? Now, if we want to create a reaction and we add another substance to this molecule, it is going to cause a reaction, okay? And what's going to happen, to make a long story short, is this carbon dioxide molecule is going to separate. Can you take these scissors and separate? Boom. Now the carbon dioxide molecule is free. Now that is super important for this particular experiment, which we're going to do next. One of the other things we need to talk about before we start our experiment, which we're getting to very, very shortly, I promise you, is a word called pressure. Okay, now, can you give me just an example of what pressure means if I put my arm out?
Like push on your arm and causing pressure.
Correct. If you're pressing on my arm, it's causing pressure. I imagine that's where the word probably came from. Press, pressure. Anyways, if we take this water bottle and I apply pressure by squeezing it, what is happening to the water?
It's rising up
And why is it rising up?
because it has nowhere else to go.
Yes, it has to go somewhere. It's not going to come out of the plastic here. Okay, it has to go out of the opening. Now, what happens, can you demonstrate if we apply a lot of pressure at one time? What happened?
The water spilled out.
It had to come out the top because it had to basically escape. Okay, great. Next is our experiment. So in this experiment, we are going to combine two substances to try to create a certain type of change. So I will guide you as to what to do, but I want you to think about, we're going to be combining the baking soda with the vinegar. Okay, we know vinegar is a word that begins with an A. That
Acidic.
it is very acidic. That is true. Very good. It's an acid. So, when we combine them, do you have any kind of guess as to what might happen?
It releases the CO2.
Okay, that's good. That is, well, that's what's going to happen, as we discussed with our model. So very good. And if we put the baking soda in the balloon and the vinegar in the bottle and put the balloon over the bottle, what do you think might happen to the balloon?
It blows up.
Let's find out. Go ahead and take the funnel and take the balloon and put the balloon on the bottom of the funnel. And can you do those 4 scoops of baking soda and put those in the balloon? Two, 3, 1 more. There's 4 half teaspoons, making 2 full teaspoons. Now, let's go ahead and take this water bottle and let's take the funnel off without spilling anything inside the balloon. And let's go ahead, I'll open this up for you. Put the funnel inside the bottle and pour vinegar in there up to about halfway. That's good, right about there. Thank you. I'll put the cap back on. Now what we want to do is remove the funnel, and we want to take the balloon end and put it over the bottle without dumping anything in the vinegar yet. Okay? Very good job. Okay. Now, as you kind of surmised or guessed as to what was going to happen, you thought that, you want to explain one more time? That the carbon dioxide
Releases the CO2.
and,
Fills up the balloon.
yes, because it has to have somewhere to,
Release the pressure.
yes, it has to have somewhere to go. Okay, go ahead and turn that balloon upside down and shake all of that in there. It looks like you were correct, man. because that balloon is filling. So the science behind this is that there is baking soda, which is made up of 4 different types of atoms that form one baking soda molecule. And when you put a reactant and combine those 2 together, the acid from the vinegar will more or less, to make it kind of short and easy, cause the reaction and cause the CO2 molecule, the CO2 atom, to be released from that molecule. And then it rises up and fills the bottle, or fills the balloon. So has the baking soda itself changed?
Yes.
Yes, it has changed because that one atom is now released, so it is not baking soda anymore. We can go into more depth as to what it actually is on the next lesson.